So this lesson is all about triangles and angles, and it goes a little bit deeper into classifying angles because the types of angles that we use to create triangles determine the type of triangle that we have. So let's take a quick review of angles as rotations, that idea of rotating a ray, because that concept is very important for the idea of classifying angles and triangles. Now, we saw in the last video lesson on angle pairs that we can take this ray, and as we move it around in this circle, we create different angles between the original ray, in this case a very small angle, and the ray that is being moved. And so we have the rotations. We get up to our first named angle when we get to there, and 90 degrees, where it is the angle that is in the corner of a square. That is why it's often called a square corner. This 90-degree angle represents a quarter turn. You started by facing, if we wanted to use the cardinal directions as a bit of a way to talk about this, north, south, east, west. If you started facing east and turned 90 degrees, you would be facing north. And so then we continue on. We have larger and larger angles as we go through, until finally we get to our next named angle, which is that, a straight angle, which represents a half turn, 180 degrees. We can continue even farther until we get to 3/4 of a turn. Now at this point, our angle is actually not this small section here, which would be a square corner again. It is, in fact, this entire rotation of 3/4 of a turn. This is the angle that we're looking at, and that is 270 degrees. And finally, if we rotated that angle back to the beginning, we wouldn't have a zero angle like we started at the beginning. We would have a rotation entirely around, and that is what we call a full turn, or 360 degrees. So if we take the first set of named angles, our first named angle is, of course, the 90-degree angle, but we have some angles that happen in between the 0-degree angle and the 90-degree angle. All those angles that are smaller than our first named angle, our 90-degree angle, are called acute angles. That is, any angle less than 90 degrees, still greater than 0, but less than 90 degrees is called an acute angle. And some examples of acute angles in the world are things like the pyramids create an acute angle when you look at them from the top, a little bit less than square. Doorstops have an acute angle down at the tip down there that keeps the door open. Each point of a star is an acute angle. A pizza slice is generally an acute angle, but obviously you can have bigger ones than that. And the Chrysler Building in New York, if you ignore the spire and just look at the angle of the sides of the building coming down, that is also an acute angle. So any angle less than a square corner is an acute angle. On the other hand, we have angles that could be greater than 90 degrees, but not quite a square angle. And so for this, we call them obtuse angles. Angles between 180 degrees and 90 degrees. So here we have acute angles below 90 degrees. Above 90 degrees and up to a straight angle, we have what are called obtuse angles. And some examples of obtuse angles are a lot of house roofs are obtuse angles. You can see the angle in the top beams going back. The Pentagon has an obtuse angle for each of its corners. And planes in the air, particularly stealth planes like this, have obtuse angles at the front of the plane. So first, we want to take a look at these angles here and decide, are they acute or obtuse? So go ahead and pause the video and see what you can do with these ones. Are they acute or obtuse? So if you looked at these, I'm going to circle the acute ones in red, the ones less than 90 degrees. These three are all acute. The ones that are circling in blue, then, greater than 90 degrees, but not quite a straight angle, are all called obtuse. So now, looking at these are the ways we classify angles their based on their number of degrees. And so when we classify triangles by the type of angle that we have. If all of their angles are acute, we call them acute triangles. If all of their angles are obtuse, we call them, or if one of their angles is obtuse, rather, we call it an obtuse triangle. And if one of their angles is a right angle, we call it a right triangle. And so here on the next slide are some examples of right triangles, acute triangles, and obtuse triangles. So now seeing these triangles, we can see that some of them have only acute angles, some of them have only obtuse angles, and some of them have what's called a right angle. I'll draw those in there. So now you're going to classify, go ahead and pause the video, see if you can classify these triangles as either acute, obtuse, or right triangles. Well, the easiest one to see is probably at this point are the obtuse triangles, the ones that have an obtuse angle, and they often look like they're tilted down in one direction. This angle here is an obtuse angle, so the triangle in the upper right-hand corner outlined in blue is an obtuse triangle. This angle in the bottom left-hand corner is an obtuse angle too, so the two triangles rather outlined in blue are obtuse. The two triangles in the center both have a right angle, so they're called right triangles. And the two triangles in the lower right-hand and upper left-hand corner have only acute angles, so they're called acute triangles. But we also classify triangles by how many sides are equal. Now this is unrelated to their angles in one way. It doesn't matter what their angles are, as long as a certain number of sides are equal. So if 3 sides are equal, we call it an equilateral triangle. Now in this case, every side is equal, and because every side is equal, it also happens that every angle is equal. If 2 sides are equal, we call it an isosceles triangle. Now this is 2 sides only. This third side down here has to be unequal to the other 2 sides. And finally, if there are no sides, because we can't really say if one side is equal, one side is always equal to itself, but if there are no equal sides, we call it a scalene triangle. And this can be of any shape as long as none of the sides are equal. So one thing you may have noticed is that in the equilateral triangle, each side has an orange hash mark. And in the isosceles triangle, each side has 2 green hash marks. And those hash marks are used to indicate that the sides are equal. And as long as those hash marks are identical on the triangles, it shows that sides with identical hash marks are equal. So you can see this scalene triangle is an obtuse triangle. This equilateral triangle, as with all equilateral triangles, is an acute triangle, and an isosceles triangle can either be like a scalene, acute, or obtuse. It could also be a right triangle in certain circumstances. So all of these things, you can classify triangles according to how many sides they have that are equal, and according to the types of angles that they have, acute or obtuse. But there are a few things other than those that every triangle has in common. This differentiates the triangles, but there are some things that every triangle has. And so among those things, go ahead and pause the video and see if you can come up with 2 things that all triangles have in common. So 2 things that every triangles have in common are that they have 3 sides and 3 angles. I'm going to call that one thing because that is the definition of a triangle. But the other thing they have in common is that for all of their angles, no matter what triangle you have, the sum of the 3 angle measures is 180 degrees. Meaning, if you took the angles of a triangle, let's say this triangle here that I've drawn, if you took the measure of angle 1, and you added it to the measure of angle 2, and you added it to the measure of angle 3, the sum of these 3 measures would be 180 degrees. And this is true for every triangle. So we can know 2 angle measurements of a triangle, and we can easily find the third. So go ahead and pause the video now again and see what you can do with this one. Each of these triangles has a missing angle measure, but you know 2 of them. Remembering that the sum of all angles in a triangle is 180 degrees, see if you can find out what the missing angle measure is for number 1, number 2, number 3, and number 4. Well, let's take a look at number one. The two angle measures that we know are 25 degrees and 50 degrees. So we know a total, 25 plus 50, of 75 degrees in this triangle. Since we know that all angles must add up to 180, if we take away those 75 degrees, 180 minus 75, we are left with 105 degrees remaining, and so 105 degrees is actually the measurement of that angle. The angle x is measured as 105 degrees. Now for number two, we have two angles that are exactly the same. I'm going to write this now as an equation that we can solve. We know that the sum of all the angles equals 180. So x, whatever it is, plus 75 plus 75 has got to equal 180. Now, if we add 75 and 75 together, we get 150, so I'm going to subtract 150 from both sides because this is what we have to do to solve an equation. These 150s cancel out. We're just left with x. 180 minus 150 is 30, so the missing angle measurement is 30 degrees. Now, looking down at number three, we also have two angles that are identical, two 60-degree angles, and I'm going to write this as an equation again. X plus 60 plus 60 equals 180. So now 60 plus 60 is 120, so I'm going to take 120 away from both sides. 120 takes care of both 60s. We're left with x is equal to 180 minus 120, which is 60 again. All of the angle measurements in this triangle are the same. What that means is that this is an equilateral triangle also. If all the angles are identical, then all the sides are identical. And finally, for number four, x plus 17.5 plus 132 equals 180. Now 17.5 plus 132 is 149.5. So I'm going to subtract away 149.5 from each side. That will take care of both the 132 and the 17.5. Take those both away. You're left with an x equals 180 minus 149.5, which gives you 30.5 as the degree measurement of the missing angle.